says draw a graph to represent the following data. Now typically, I'm going to tell you that most dates are always going to be in the x column. In other words, my x or my independent values will always be dates or time. This will almost always be dates or time. Okay? So let's readjust this graph to represent 1, 2, 3, 4, 5, 6, 7. Now let's go by, let's see here. I'm not going to go on. So let's create some data, or create this graph for data. So let's say this is 1, 2, 3, 4, 5, 6, and 7. And notice how all my values here for x are all positive. So I don't need this side at all. So I can improvise by doing that. And all my data seems to be positive here, right? So I don't need this. So now the first quadrant's the only thing I'm worried about. So you take a normal Cartesian coordinate system and you break it up to where the data tells you to go. So the reason why I erase these 2 quadrants or 3 quadrants is because the data is only going to be positive x's or positive independence over my y's. Okay? Now look at my y values. Look how big these numbers are. Should I change these numbers? Yeah, we better change these guys. So, you go by 10. Let's see, let's go by 15. So I got 15, 30, 45, 60, 75, 90. I probably don't need to get to 90, I don't think. I need to get that high, I suppose. Let's go to 75. Okay. Now let's plot our data. So at 1 I get 35, right? So 1 I got, let's see, I got 45 here, 30, I'm going to come right in the middle, something like that. And I'll say that's 35 there. That's my first data point. 2, I got 24, so a little lower than 30. So I can say this is 24 down here. And so on and so forth. 3, I got 9, which is less than 15. It's down here. So I'll say that's 9. And then 4, I got 15. That's right on. 5 is 27. That's just about here. And 6, 32. Just about here. 7 is 40. So something like that. So there's my data. What a big V looks like, yeah. So they also say that you can identify these guys. You can say that this is 135. Do that. You can say this point here is 224. This point here is, looks like it's 39. And so on and so forth. Have a little bit more specific graph, but that's all right. You may want to you can also download from the internet free graphing paper. Okay? So if you got a printer and a computer at home, you can do that.
Can we just make it on there if we want to?
Yeah, you can make it too. Just for time's sake, I suppose. So. Now let's do one more thing. Let's see here. Now we want to use a particular type of problem. For example, let's do this using graphs. So I'm going to erase all this. This is pretty easy. Okay? We don't get too heavy into graphs. We will eventually when we return from Thanksgiving. Now you all know you're not coming next week, right? So, but you have an assignment. I'm going to pass that out now. Why don't you do this? Oh, I got here. I'm going to pass out this assignment first. This is not your assignment that's due. This is due when we return. A little graphing assignment. I had to staple these. Some of the staples. staple a few more. Hang on. This is kind of a bigger, this is sort of a bigger graph, and it'll come out to be a picture of some sort. So do it pencil first. I recommend doing pencil just in case the picture's a little skewed and maybe you missed one point or something. So the second one is really identifying the points by putting the coordinates down, and then find the letter associated with each pair. So you're going to do a little bit of both on this. So fairly straightforward assignment. That's part of tonight's homework. That's this handout number 6 here. So I'm going to put handout number 6 on the top, and then for homework page 202, 1 through 5 all. Okay? All right. Next coming is the assignment that I've been talking about. It's blue for a reason. So you know that it has a lot of work tied to it, so you got to spend some time on it. And it's due by, like I said, Tuesday before noon, I said. Okay. Yeah, sure did again, huh? Oh, I'm sorry, kids. Okay. So, that's that. All right, now one more thing I want to do is I want to do one more. I want to look at page 199, and it's got a word problem there, and it says Martin and Nancy go shopping and spend exactly the same amount of money. So Martin and Nancy go shopping. So I'll call one M, I guess. Put M over here. And Nancy, I got here N. It says at the first stores, at first store, each spends $1. Okay? So I spend $1 here, spend $1 there. So when you're doing this word problem, you got some for homework. If you want to set it up, you're going to set up two things. You're going to set up the Cartesian coordinate system and a chart. So that's the first thing you want to do. Okay? We call that A. So for each one of these, you want to set up some kind of chart and some Cartesian coordinate system. The second thing is you want to read the problem, make sure you got all the data right. So at the first store, each spends $1. The second store, $4, and third, $10. So 4 and 10, 4 and 10. This is all money. I just put money up here. This is not like the homework, but this is sort of a lead up to it. We can draw a graph based upon the points, and so the points, they do an extra graph, but you can actually go from just one. Now the thing is, one of my pet peeves is, give me a graph, but I want you to identify, you have to identify the axes. In other words, you always have to have some kind of number representation. A lot of students do this. And they don't identify what these are, and they don't identify those. And I always take off points for that. Okay? So I should identify this as 1, 1. This is 4, 4. And this is 10, 10. Okay? So make sure you identify. In fact, from here you can erase this and this and get something like that. Now, what makes these a little harder is the algebra. You can have ones that have tied up to a little bit of algebra. In other words, the second example, the time at each store, so that's done right there. I've done graphing, what was asked to do. I said I had to draw a graph showing the information, and first we make a table and given facts. Then we draw the axes. So you don't have to draw 1 to 10. All you have to do is draw just the significant points. Okay? So if all I got is 1, 1, then I'll just basically label 1, 1, 4, 4, and 10, 10. This just tells me that you know what to look for. Okay? You don't have to give me one, you don't have to do this. So you don't have to have this all single and then, you know, represent it this way like they do. All you have to do is just give me the pertinent information. So if we're only just doing 1, 4, and 10, then that's all I really need to see. It's 1, 4, and 10. You guys understand that? You with me here? Okay, let's do another one. The time at each store Nancy spends $1 more than Martin. So for example, when Martin, so this is the second example. So I have Martin, who spends $1. Nancy spends $2. If Martin spends $2, Nancy's going to spend $3. And then 3 to 4, and then 4 to 5. So there's a problem where one is spending more than the other. So you're representing that data on the chart. And then when it comes to graphing that, again, it's only the first quadrant, and let's just use 1 to 4. So 1, 2, 3, 4. And then 1, 2, 3, 4, 5. So here again, 2, 3, 4, 5. And then plot your data 1 to 2, 2 to 3, 3 to 4, 4 to 5. And you're done. Okay? So that's what's meant by graphing data. Let's try one more where you're given some sort of algebraic expression. Everybody with me on this? Okay? Let's try one more, and we're done for today.
You got a log and capture page,
So this would be another example. So let's say this time Nancy spends twice as much as Martin. So Nancy spends twice. A lot of people had struggled with this word twice as much as. So the times Nancy spends twice what Martin spends. Let's say twice what Martin spends. Okay? So if my data is going to look like, if Martin spends, now Martin is considered the independent variable here. So my Martin is going to be here. If Martin spends $1, what's Nancy going to spend?
2.
2. That means twice. Some people think it means the same as squared. It's not. So if Martin spends 2, Nancy spends 4, 3, twice is 6, 4, 8. And so in a sense, the word twice means 2 times m equals n. This is the formula for what gave us those points. 2m gives me n. So if m is 1, so I can put that down here, I can say 2m equals n. So if m is 1, I get Nancy's 2. M is 2, I get n is 4. You guys follow what's going on here? So this is considered the equation for this problem. Okay? And then from there you can plot those points out. So they're all positive again. Let's label this guy 1, 2, 3, 4. That was the pertinent information. And then let's go by 2's here. 2, 4, 6, and 8. So at 1 I get 2. At 2 I get 4. At 3 I get 6. Or I get 8. And I can connect those dots and call it a linear equation. This is called a linear equation because it's straight.